Hi everyone, I am Suprakash, Research Scholar, Department of Electrical Engineering, IIT BHU. Okay everyone, let's start the session. I have taken a question first for a half bridge converter, half bridge DC-DC converter. A half bridge DC converter is designed to provide V naught is equal to 10 volt, where Q1 and or Q2 of half bridge is switched on for a dt time period. It means D2 ratio is D at an efficiency of 80%. If the input voltage is 30 volt is applied to this converter with a duty ratio of 0.4 at 100 kilohertz frequency, calculate the RMS current flowing through diode D1. It means secondary side diode. So used in the half bridge converter D1, D2. If the input power supplied is 10 watts. TS is the time period, it means switching time period, or Q1, Q2 gate. Okay. A half bridge converter looks like a bridge converter with a transformer and a buck converter, like a push-pull converter, forward converter. This one half bridge means two switches are used, and full bridge 4 switches are used. Isolation transformer. Secondary side look like buck converter. Half bridge converter, full bridge converter, push-pull converter, and forward converter. All of these are buck converter category only, and non-isolated. Is isolated converter like that. If a transformer is used, it means isolated converter. Inductor is one capacitor. It's on the load resistance. Inductor voltage. This one is the diode D1, and this one D2. I take it like a VP, primary side voltage of transformer. Dot polarity I taken turn ratio is n times to 1, primary to secondary turn ratio. This is the half bridge converter, DC-DC converter. Asking about the current, RMS current, calculate the RMS current flowing through the diode D1. What is this current? This the RMS current is asking you this question. We take this one voltage like a Vx, the node voltage. Then what is the Q in on? When Q is on, Q means switches Q1 is on. When Q1 is on, it's a closed circuit. The circuit is behave like this. Vp is VDC by 2. This one voltage divided into two part, VDC by 2. There were two capacitors connected in series at same rating. So also take as a C1. This one is the same rating. That's why half of the voltage divided there. This one is the Vp. Vp is VDC by 2. Then what is the Vs? Vs is transfer to the secondary side. And this one is the dot polarity. This one positive. The current flow like this. And Vx is same as the Vs. Oh, yeah. Then you can write as Vs is n Vp divided by n. Vp is VDC by 2 into 1 by n. And Q1 is off, it means Q1, Q2 is both are off. Then this voltage Vx is 0 because of this voltage is the same current flow through this. Then this voltage is 0. Then VL is a minus of V0. Here you can written as a VL is a Vx minus of V0. And Q1 and Q2 is on for this in both condition. If Q2 is on, this is closed, this one is open.
Hello.
Yes, sir.
We have to have a voltage sharing through resistance also, C1 across C1 and C2.
It's a capacitor, yes, sir. Half
We
of the
have to have
voltage.
resistors.
No. They are
No,
not resistor. This is only capacitor. If you two capacitor are connected in.
resistors are not needed to
No.
equalize.
No. If you have a resistance, if you add this one resistance, it means the losses will increase. That's why you use the capacitor, charging, discharging like that. The losses will be decreases. But in practical cases, capacitor have a ESR, equivalent resistance, but it was connected as a capacitor only, two series capacitor. Is the same at the same value, then you will divide it equally. Like if you take if you read about the inverter, same thing is applied there.
Here also we'll require the walk-in capacitor.
Yes, same everywhere. Push pull forward
The
converter. Yeah.
primary winding.
Yes.
Okay.
Because of this, Q1, Q2 is not the same. For manufacturing, it have some differences or some manufacturing error also. That's why flux of
And the
walking
C1,
phenomena occurs.
C2 also, will it be equal? C1, C2?
Yeah, this one is same. If this one is not same, then this will not equally divided VDC by 2. It is a different thing. If this one is different, then in positive and negative polarity of a transformer is a different voltage occurs. That leads to the saturation to transformer.
Mm-hmm.
That's why it should be equal. and this should be equally voltage divided, like VDC by 2, VDC by 2 only. If Q2 is on, then current flow like that, then Vp will be minus of VDC by 2. And Vx will be same, because of this one is a positive, this one is a negative, this current flow like that. Then Vx will be same here, applied plus connected to the Vx, minus connected to the ground, so Vx will be same. In both condition, on, if when Q1, Q2 off, this one is a minus of V naught.
Sir,
Yes.
sir, at that, when Q1 is on, why it is written both Q1 and Q2 are on? That at the right side of VL equal to Vx minus V naught.
No, this only for the VL only. Looks like only for VL. I taken like downside. Don't worry. It means VL will be same when Q1 are on or Q2 on. In both conditions,
Oh,
VL will be same. Because of Vx. Vx will be same, and it means VL will be same. And both are on and both are off, then VL will be minus of V naught.
no, sir, at a time only one switch will be
Yes,
on.
yes, only one switch at a time. I taken like if Q1 is on, then VL will be same, and Q2 is on, then VL will be same. That's why I written as a V1 and V2 is on. Then if you confusion this, then to remove it at all. Written like if Q1 on, then VL will be Vx minus of V naught. Q2 on, VL is Vx minus of V naught. Inductor current increase like that, minimum to maximum and maximum to minimum. Total time period is this one, Ts. This one dTs, Ts by 2, and Ts by 2 plus dTs, and this one Ts. If you apply for the cycle, then dt will be twice for d1 and d1. This one is a inductor voltage occurs at 2 times in a cycle. So if you take a bolt second valence equation, but here the duty ratio is 2 times duty cycle here because of the over a cycle duty cycle dts divided by ts by 2, of that you can take as duty cycle cells 2d because of this one dt1 and dt2. That's why I written as a 2ds. VL is the when switch is on, Vx minus of V naught two d ts plus minus of V naught 1 minus 2d Vx into 2d minus of 2d V naught minus of V naught plus of 2d V naught equal to 0. This one is a cancel out. V naught is equal to Vx into 2d. Vx in both condition Vdc by 2 into n so by n because of the turn ratio of transformer. So this one V naught and output is Vdc by n into duty cycle. Same thing if you apply for a forward full bridge converter, then Vx is a Vdc only, not a Vdc by 2, and that time the output voltage is 2d into Vdc by n. But the question is given that asking about the RMS current are flowing through the diode D1. We have an inductor current, this one. Average of inductor current is I0 output current. If you take our output as the average current, for easy calculation I take a D1, ID1. Like when switch 1 Q1 is on, okay, this Q1 is on, then what happens? If Q1 is on, then whole current passing through the diode. This one ID1, like a written as this one is I0. After when Q1 both are off, Q1 off or Q1 Q2 both are off, then that time IL current flowing like that, half of this one, half of current flow from D1 and half of current flow from D2. At that time this one current is half I0 by 2, and when Q2 is on, then Q2 is on, it means D2 is conducted and D2 is will conduct, then this one current is 0. After that when both are off, the same equally divided half of this one, so I0 by 2. Then what will be the ID1 RMS current? If you find this one RMS of this current, this waveform, then you can find the ID1 RMS. For a square wave waveform, if you find RMS value, then take as RMS like ID1 RMS, take a root of whole, after that magnitude square divided by 1, magnitude is I0 square divided by 1 into how time is present. This one is time for dt, dts, then total time period divided by total time period is ts, plus This one same thing, I naught by 2 square divided by 1 into how much time present, 1 minus t 2 years, divided by total time period, plus this one 0, then 0, so this one I naught by 2 into this one also 1 minus t ts divided by ts, whole of into whole of coming in the root. TS cancel out, this one I naught square into d plus I naught square divided by 4 into 1 minus d, this one 0, plus I naught square divided by 4 into 1 minus d. Final RMS you can calculate like take a I naught common, whole of the, okay, so then we find this one d plus add this one, then we find 1 minus d divided by 2. It means duty ratio, you know about duty ratio is given the 0.4, but output current is not given. Then find the output current, after that find the RMS current of diode. Input power is given 10 watts and efficiency is given 80%. Then what is the output power? Output power is efficiency into P in input power, 0.8 into 10, 8 watt. Then what is the output current? Output current is output power into divided by output voltage. Output voltage is given as a 10 volt, 8 divided by 10, then diode RMS current I naught root of d 1 minus d divided by 2, 0.8, 0.4 plus 0.6 divided by 2, plus 0.67 ampere. Okay. The second question is given referring the question number first. Calculate the number of turns required to achieve the required specification. Let's talk about the number of turns. Number star can you find from here? Output voltage is given, not with the number of turn. Number of turn is VDC to DT ratio divided by V naught. VDC is given 30 volt. VDC is V in same is 30 volt. Duty ratio is given 0.4. Output voltage is 10, 1.2, and take a maximum number, integer number is 2.
Sir,
Yes,
in that terms ratio n equal to 2.
yes, yes.
Uh, Sir, it is actually it is n1 by n2 equal to 2, right?
It is a ratio, no?
Ratio, turn ratio, and it means
We want to calculate number of turns.
NP by NS, like that.
So how we calculate the NP?
Sir,
Oh, yes,
no, sir, I have the question till because sir that NP by NS equal to 2.
yes,
That NP is the this NS is the one half of the secondary winding, right?
yes, yes, sir.
Okay.
It means if you have a number of turn, primary turns is 2, then secondary turn is 1. If a number of primary turns is 10, then secondary is 5. Like
Yeah,
that.
one half of the secondary is 5.
Yes, yes.
How to
Okay.
calculate the primary turns?
No, like you can't calculate the directly number of turns. It's on the number of turns ratio.
Ratio.
Sorry for this one. Turn ratio only you can calculate.
So with magnetics, it will be
Yeah, if magnetics information is given, that's time you can calculate the
then
number
NP
of turns.
calculate number of
You
turns.
can calculate the directly number of turns. Is it,
Here it
is
is
it
asked that number of turns. Question second, number of turns required to achieve the required specification.
I think this one is a printing mistake. Only number of
It
turn
is not.
ratio.
Uh,
This was not possible only for this information. Like is given as a,
because
this one is
there
given as a number of turns like n only.
uh,
A hint is given here.
here also it is given number of turns
Number
n is equal
turns
to n p.
n only. Yes, sir. That's
But it is wrong actually.
number of turns. This one number of turn
Ratio.
turn ratio you can say it like the turn ratio.
Turn ratio. For that we have to have that cross section area and everything, that
Yeah,
AP product and all.
windows area and winding a lot of
Yes,
things.
lot of things.
The second question we take the gate driver circuit given here. The following parameter like VCC is a 15 volt. If you observe this one, this looks like a flyback converter.
It is a forward converter.
No, no, flyback converter, not a forward converter.
The dot conventions are same here for primary and secondary.
No, that's in this one is not given. That converter is different.
But when the coil is energized, that time itself the pulse is going to appear at the secondary, no?
Yeah, this one is different thing, but this one
So
looks like a flyback converter.
uh,
Not
rather it is forward converter without reset winding.
without output, you
Reset.
can say without output winding like a LC.
Hmm.
Can say like a forward
Without
converter.
LC. Yeah.
Yeah. And switch is on, then voltage transfer here the primary side, and switch is off, the remaining energy reset from the diode and diode and resistor. This one required where the upper side switches they are like a buck converter. If you
Hmm.
observe a buck converter, this is the buck converter switch Q. You can see MOSFET. MOSFET switch. This one is a drain source. This one is a gate. So it required a gate pulse Gale press you can generate from the microcontroller. So microcontroller given as pulses and ground. One is a ground, this kind of a pulse like this one. Then this is the only 5 volt. Microcontroller can generate maximum 5 volt or 3.3 volt also sometime. Some of microcontroller generator 3.3 volts maximum peak to peak value pulses generated like 3.3 volt, and some of the microcontroller generator 5 volt. It's some 5 volt maximum generation of pulses of any microcontroller. Then for a high rating of MOSFET, it will require like a 15 volt of pulses or 20 volt like that. Then you should then it require the gate driver to boost this one. Simply connect a gate driver circuit, give this one. If you have a 8 pin gate driver circuit, so they are not connected pin, so connected to the positive, second connected to the ground, and this connected to the VCC of 15 volt, which when you want to generate 15 volt, 12 volt, 20 volt, anything you can give 12 volt, 15 volt or 20 volt VCC, and this pin is connected to the ground. This one is generated as a pulse, both the pin. Like if you take HCPL 3120 driver circuit or FOD 3184, both pin are same. In this converter, like use this one FOD SCPL or FOD 3184 FOD use for drive the MOSFET in a buck converter, boost converter like that. This one is the pulses generated like if you take given as the 15 volt, this one is a 15 volt pulses. You take 12 volt VCC, then 12 volt pulses is given. Then this,
Sir, this is HPC. What is that?
SCPL,
SCPL.
yeah,
HCPL. SCPL 3121
3120.
20.
SCPL, HPCS as something I forgot. The SCPL 3120. The gate driver circuit, a simple gate driver. This one is a simple gate driver. You have 4081, 3184. Both are the same pin configuration, and you can use this one. If you have a 15 volt, if you require a 15 volt pulses, then simply use this one. But only for buck converter cases.
These are not floating, no? These are going to grounded.
Yes, that's why the some problem occurs in drive for the buck converter. Looks here, if you have a connected this one from this pin, and ground should be connected to the source in driver.
But that but it has to be isolated.
There's a problem if both the ground are same, this one ground and this one ground, this one also ground. If negative pins here,
Then problem.
yeah, if this one is also ground, if you take it as the same ground pin for the both this one is a high power circuit, this one low power circuit, both are the same, it means this pin connected to this pin, this will connect due to this one with this ground pin and connected to the here, and this ground pin also connected here. If VCC is a same ground pin, at that moment you can't drive the buck converter like that. This one is a whole of circuit connected through the VSS only, because of this one is a drain and this one source connected to this one through the lower circuit. That's why you should require the isolation circuit.
Sir, explain this again.
Okay. One looks for the boost converter, then okay. After that I explain for the buck.
Sir, we need to isolate the grounds of gate circuit and the converter.
Yeah.
Yes.
Okay, 1 second, I will. This one the gate. Okay. In this condition, both ground are same. This one is ground, and this one also ground. In the boost converter, you can connect it directly through the
From the
ground.
microcontroller, I can give the pulse directly.
Yeah, you can microcontroller. You have a microcontroller ground, and
Any controller,
this one
yes,
is
yes.
a driver ground, and you can connect all the ground is same. In a boost converter, a buck boost converter, because of the switches connected is
Are
the lower side.
okay.
It means a source connected to the ground. If a switch source, if a MOSFET source, drain source, gate, theta means na, the source is connected to the ground, and that condition you can connect directly ground and gate pulse you can give like that.
So here no isolation is needed.
Yeah, there is not isolation and not boost trapping circuit also for drive this type of circuit. Then this is not required isolation circuit between the high power circuit and low power circuit, because of the ground source are connected to the ground. But here is a different thing. Source is not connected to the ground of MOSFET. In that means you should have a isolator power supply for this driver circuit. You should have an isolate power supply. After that, that ground and that ground is not same. In this condition, this ground you can connect by the source to drive the buck converter. This one is the issue. That's why this type of circuit is used for isolation, because of you can see you can look see here, this one circuit is different, and this one is a circuit is a different ground. This one also generated a pulse only. Here is given as a pulse only. This one a pulse positive, and this one is a negative pulse generated. This is already connected to the. This one is we have this one is only for BJT, but you can connect a MOSFET also here. You can connect this one is from a gate, and this one is the source. This one is a drain. You can observe this one. This circuit is connected in a buck converter. Because of this the ground is different. This one's pulses given from a microcontroller. Pulses coming from the microcontroller only. This one is a high. It means this one high. This one high. Then this one current is flow. This one switches high. If this one is low, then so off. This one off means remaining circuit discharge through the diode and the resistor. And this one is a 0, and this switch is off. And this type of circuit required for the floating MOSFET or upper side MOSFET, upper side MOSFET, upper side switches is known. Come in the questions is given the 15 volt VCC and peak magnetizing current is given, this one as a 5 ampere. Forward voltage drop of D of 5 is given 0.7 volt, and this one is given as a 30 ohm. Then what can be the minimum collector emitter voltage rating for Q1? I draw the circuit only for this one. Okay. Look here.
हाँ 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 थोड़ा
This one is 15 volt. When switch is Q1 is on, it means this one the charge Xi, this one a transformer and to give that voltage in secondary side. But same time switch is off, the current flow like that, we written as a Vp. But sometimes if the switch is on, this one is off. The switch is off, you can say like a voltage appears here Vq. Then if you current flow like that, then remaining if the switch is off, then current flow in same direction like that. At that time, this one will work behave like a source. That's why the polarity will change, and this one current is this one positive, this one also positive negative current flow like that. At that time, if you apply a voltage KVL, then VCC, this VCC you can say this one connect like that. This one positive, this one negative, or you can treat it as a VCC here, 15 volt. This one positive, you can take as this one ground pin. Negative, this one is a VCC. If you apply KVL here, then take from here in a loop minus of VQ plus of VP plus this one VCC is equal to 0, then VQ is equal to VP plus of VCC. Then what will be the VP? When the switch is off, when switch is off, the current flow like that, then this voltage drop and this voltage drop appears on the transformer primary winding. Vp is like Ip into Rs plus of 0.7, it's given which is Vt5. Ip is given 5 ampere, is given 5 and Rs is yes.
In writing KVL, dot and you took it as a negative or positive.
No, I have taken like when the switch is off, then polarity will be changed, na. Polarity will change. This circuit we have like a source. If you have like a source, it means
So
current.
this first equation is when switch is on or off.
When switch on, then this one restore the energy. After switch is off, then this release the energy through the resistor, and that
So I'm
can
asking this first one, sir, where you boxed, no, where you have
what?
this equation. First one, VQ equal to VP plus VCC.
Yeah, this one switch is off only, not on. Because of this voltage occurs only if when the switch is off. When switch is on, this voltage will be 0 because of current flow like that.
Yes.
That's why when switch is off, in that condition this KVL is appear. IV is given 5 ampere and resistance is given 30 ohm plus this one voltage drop is 0.7 volt. Then Vp is 150.7 volt. And what is the Q? VQ? VQ is Vp 150.7 plus a VCC is then 15 volt or 15 volt. Then VQ 165.7 volt. It means VQ reverse voltage blocking voltage of this switch Q1 should be greater than or equal to 165.7 volt. This one is the minimum value. You should provide the greater than this one value. Question number refer the question number 3. The maximum duty ratio that can be achieved is 0.6 per 100 kilohertz operation. To increase duty ratio till 0.8 for the same frequency 100 kilohertz operation, what should be the approximate the new value of resistance? So now 5 is
Sir,
yes.
here we have to consider VCQ is equal to 165.7 as this one
Yes, yes, yes.
for this condition. If the duty cycle is 0.6 to 0.8, so we have to stick with this.
Point this one given a point duty ratio. I think it's the same duty ratio is given point
No, here
0.6
here
only.
it is not given,
Yeah.
but here in this next question it is said that
No, in
it is
this
point
question is given as the current given.
current is given,
Maximum current is
and
given, then
now
say,
it is referring for that maximum current 0.6 volt, zero
yeah.
point 0.6 duty cycle.
Yes, sir.
So
You
then
point
we
6,
had,
yeah, if you given for point 6, but you have not mentioned actually for current duty
not this
ratio.
not this question. Next question it is there.
Yeah, this one is a different. Don't mix this one. Only take a value of this one current. If a current is given like a 5 ampere, then take as a 5 ampere only.
But
So
here
for
we need,
calculating VCQ,
Yeah.
for calculating this VCQ means maximum voltage that switch can sustain.
Yes.
We should take minimum D or maximum D.
This one is minimum D at 0.6 only. If you increase this one, then it should be increased.
but here intention of this question is that we have to keep the we have to change this RF to so as to accommodate that VCEQ.
This time if you increase this one D2 ratio, then energy will store more na.
We will need
I square, half I square.
mm,
This energy will be increased.
yes.
And that time you should increase the resistance to discharge, to dissipate this energy. If you take a like a IP, if power is calculated in the resistance, you know about IP RMS square into RS resistance into time period when time off period is the same as the on period is stored energy LIC square. But this one is the maximum value is given, then it should be constant. You can't increase or decrease this one. If you same current apply, then energy stored will be. But here T of time period is different. That time this energy to discharge the all energy, then resistance should be a different value. Life if you take as a maximum value, IP is like that. So peak value is given IP when switch is on, it means T on time. This one T, this one is the T off time.
Sir,
Yes.
sir, in the last question, we were discussing the voltage that the switch can block. So does it depends on does the blocking capacity of the switch depends on the duty ratio?
This is not actually, it depends because of the, if you VCC is on, then it will depend on the current storing energy, then what will the current flow through this. If this current is flow more, then this drop will be more, same drop appears on the winding, and that time as BQ will be different. All of depending on the current. If current will be same, off on time, if in the both condition current will be same, then this voltage will be same. If current will be different, then this voltage will be different. But in this condition, if you increase the duty ratio, if you increase the duty ratio, then you have less time of turn off time.
Yeah.
In that time, you should discharge dissipate the all energy of this transformer to this resistance.
Yeah. For the R should increase.
Yeah, that time you should increase this resistance value to dissipate the all energy, all store energy at that time in a minimum time, in less time of first one. Like if you have a 0.6 duty ratio, after that you increase the 0.8 duty ratio, it means you have only 0.2 or 0.2 of turn off time duty ratio, and before time you have a 0.4, like that. Turn off type, if you have a 10 microsecond as a duty the time period, then you have a 6 microsecond is a on period and 44 microsecond is a off period. But if you increase this one, if you increase this one to 0.8, it means we have only 2 microsecond to dissipate all energy or all stored energy in the transformer.
Yeah.
In that condition, you should have required, it will require the resistance should be more to dissipate the all
Sir,
energy.
here,
Sir, as the duty ratio, as they are increasing the duty ratio, which means the rating of the switch also should be increased.
No, if this is, yeah, if this one is will change.
Yeah.
Yeah,
So
the
that
resistance
it
will be
has a direct
changed.
relationship.
Yeah, the resistance will be changed, and voltage drop across it also change or increase. If this one increase, then the duty, voltage across the switches appears also increases.
so that inductance value on
Yes.
the winding, and will form while discharging it. It looks like a RL circuit. Then we have to take the starting just peak value when it starts decreasing for calculating the voltage drop.
Yes, sir. This one is a different thing, but here I only take as a ideal cases like that. If it take as a maximum current flow, like a linearly current flow, and linearly decreases, like this one. If this one is exponential, then the calculation is very complicated, RMS value like that.
Okay.
But here only this
What is the slope, sir?
will
What
be,
will be the slope?
will be take as a linear slope. When switch is on,
Linear slope.
when switch is on, then this winding appears as a VCC directly. That's why I take as a linear, a constant voltage appears here. That's why I take
No,
as
while
a linear.
discharging, when it is off.
Yeah, while discharging, then that time this is different thing. But I take as a ideal as a linearly only. But this is not linear because of the RL circuit. This one is a different thing.
Yes.
Because of the RL circuit, this one is exponentially decreases in order. But this one the calculation is very complicated. That's why I take as like a linear. It's the approximate circuit. It's not exact, but you can say the approximate is the same. This only current flow through the diode, through the resistance IR5. When switch is off, then this current will flow. Then this peak current is IP. Then what will be the RMS of this one? RMS value for triangular waveform, so take a maximum peak value IP square divided by 3, square divided by 1 for a triangular divided by 3 into time period, where is on, this one off time period, where is what time is it to present. So T of time only present, that's why I take a T of divided by your total time period for any triangular waveform. For a square waveform, same thing appears, but here is a 1 only. Then you can say like IRMS square is equal to IP square divided by 3 into T of divided by a total time period. So what is the stored energy? Half Li square. This both energies should be same. Then IRMS square IR hype RMS square into R5 into T of top time. Energy is half of Li square.
बंद करना फैन सर.
This one will be should be a constant for the current is the same. IRMS is IP square divided by 3 into T of divided by your total time period into R5 into T of, it should be a constant as the same. Then what will be this one is a constant because of the time period is same in both condition. T of change and R5 is R5 is change. Then R5 you can say is indirectly proportional to the T of time period. Okay, square from here. If you calculate this one, all of is a constant, then T R5 is indirectly proportional to this one. Then you can say R5 new divided by R5 old is equal to T of old divided by your T of new value square. Then what is the R5 new value? T of old, what is the T of old and new? Is given as duty ratio of D old is 0.6, new value is 0.8, time period is given TS 1 by 100 kilohertz,
10 microseconds.
it means 10 microsecond. Then what is it off period? T of
2 microseconds.
old is a 4 old is a 4 microsecond and T of new is 2 microsecond. Apply this one here. T of old is 4 microsecond by 2 micro square into R5 old. So twice square is means 4 into 30 120 ohm. A new resistance you should require. You have required to never like that.
So here, sir,
Yes.
here we have taken this energy stored in the previous one and new one same one half L.
Yes. It will depend on the only current only. What will you have current flowing through it? The maximum current.
Sir, for the duty cycle, if it is changed, then IP will be different.
No, because of the IP is fixed given, like a 5 ampere only.
So we have to consider IP for
Yeah.
both the
Both
conditions 5
conditions is
ampere.
the same, yes. Both the conditions given as the maximum current is this one.
But in practical, it won't happen. IP will be different. If it is 0.6 and if it is 0.8.
The current will be like IP
Because magnetizing current is going
into
to increase.
dt by L, like that.
Yes, it is going. L is going to be the same.
This one
Vs
is same, T is same, Vs is
but
same, and dt is equal.
dt is going to change.
This one, if you take a maximum, it means 0 to maximum
Yes.
IP, then it depends on the duty ratio. Duty ratio increases, then IP also will increase.
So
But here is not mentioned like that. That's why I have taken like same as IP. Next question is given the speed of a base driver circuit, same as that is this one also a driver circuit. Drivers Q1 IC1 is given like is 1 ampere. VCC is given 20 volt, VS is 30 volt. Q1 turn off time of Q1 is 100 microsecond, which is 5 times of R2 time constant. This one is a R2 time constant is given. 5 times of 5 tau, it means a T of is equal to 5 tau. If you take this one a time constant 5 tau you can take as in a steady state like that. 5 time you take a steady state, or you know about the settling time in any system, in a transient system, transient behavior, the different type of thing, time, settling time, rise time, peak time, like that. You know about that? If you have a step
Control
response like that, given as a step input is 1, this one is
Is the time to reach 90% of the steady state value?
yes, this one is settling time 90 and 95%, yeah, 98%. It depends on this different thing. If there is a 3 tau, it means 95%. If you have a 5 tau, it means 98%. If you given as a 5 tau, 5 times of RTC, R2T is a time term constant tau is given. It means that this circuit will goes in a steady state. In a steady state, this capacitor behave like open circuit in DC circuit, DC time period, like that. If you take this one 5 tau, 3 tau, this one, and this one 5 tau, take as like a steady state. It means this one is a constant voltage. Constant voltage, it means this one is the open circuit. Behave like open circuit. Capacitor in DC circuit behave like open circuit, and inductor is as a short circuit in DC circuit. Behave like that. If this one is an open circuit, in off time period given, and switch is off, then whole of current flow like that. A circuit completed from there, from here. That means you have required the saturation of this one, VQ2 saturation, and VB base to emitter voltage. You require this one, you apply a KVL and find the value of R1 directly. For this, if you apply a VCC is equal to this one voltage, VQ2 saturation, plus this one IB current, IBQ1 into R1 plus VBQ1. This voltage drop is equal to VCC. What a value given here? VB, we required VQ2 saturation, IBQ1 and VBQ1. V saturation voltage given 0.2 volt, VBQ1 given 0.7 volt, and IC given, IC1 given 1 ampere. This one, then you can calculate IB1. IB1 is IC divided by of beta saturation. HEP saturation is given as like 10, then IB1 is 0.1. Then apply this one and calculate the R1 value directly. This one is a 20 volt, 0.2 volt, 0.1 into R1 plus 0.7 part with the R1 20 minus 0.9 divided by 0.1 90.1 also given a value of R1. Find the next question will find asking about the value of C capacitor. Then find time of R2C is a turn off time T off, and T off is given 100 microsecond. And what is the C? 100 microsecond divided by 5 into 191.105 microfarad. For the DC-DC converter shown in the figure, the on-state resistance of MOSFET and diode forward voltage is given 40 milliohm and 0.8 volt respectively. This resistance is given and this one diode voltage drop is given. Regarding the switching loss, the power dissipation in the MOSFET. Power loss in switches is two types: conduction loss and switching loss. Switching loss occurs when on and off time period, like if a switch this one is a current and this one is a voltage, and this one is a on time. Same thing occurs in off time period. Switch is on because of the voltage 0 and current is maximum, and after the switch off, current will 0 and voltage maximum after you on the switch. This is the switching loss time period. When voltage and current and time period is given, switching loss energy, you know about the V I into T, then voltage here, current here, and time also here. Then there is some losses, and in the power loss of on time and conduction time, you know, I square R loss, I RMS, switching RMS into R on. There are two type of losses in MOSFET. So divided by time period is the power. Two type of losses occurs in switches. This one is known as the switching loss time period. Switching loss, and this one is the conduction loss. Here is given the neglecting the switching loss. It means there is given as a switching loss. It means this one is a sudden 0 and suddenly on, like ideal cases. But here given as the switching loss is 0, then neglect this one. And power, asking about the power dissipation in MOSFET, it means the resistance losses of, what is the resistance losses when switch is on? It means in on conduction, due to ratio is given 0.4. This one is the buck converter only. Then first one, find the RMS value of only one switch present here. Then find the RMS value of switch. After that, apply I square R, and simply find the RMS. Simply find the loss, power loss. You can rewrite the buck converter like this one. Okay. Dhananjay sir, please off your mic. For the drop of voltage, I will take it. Then what happens? The voltage of inductor one is on.
फॅन बंद कर ना सांगतो खूप.
So Dhananjay sir, please off your mic, please.
Yes, yes.
There are some disturbance. When switch is on, that this one will close and power flow like that. Then VL, you can say this one IL. VL is equal to Vs minus of V naught minus of IL into R. When the switch is off, then same current flow through the diode. Then at that time, minus of V naught plus Vf, forward voltage drop of diode occurs in the inductor. Apply volt second balance. VL on time, it means dt, plus VL off time 1 minus dt is equal to 0. On time is Vs supply voltage minus of output minus of voltage drop across the switches due to the resistance, on resistance into dt minus of V naught plus of forward voltage drop of diode and find the output voltage from this equation. So is dVs minus of dV naught minus of d IL into R on minus of V naught plus of dV naught minus of Vf 1 minus d. This will be cancelled out. This one is the average of average voltages. Then you can say as V output is equal to dVs plus of IL into D or on, sorry, so minus of Vf 1 minus D. In buck converter, you know about the IL current. Average IL current is same as the average output current. And average output current you can take as output current into resistance. Divided by resistance, or voltage into resistance. Sorry. Output because of this one is the average current of inductor. Average current of a capacitor is 0. IC average is 0. Then this average IL average is same as the I output average, and this one equal to V naught by R. Then you can simply replace VL IL through the V naught by R. Then you find a V output dVs minus of V naught into D into R on divided by R 1 minus D. Transfer the left hand side of this quantity, then you find 1 plus D by R into R on is equal to dVs minus of Vf 1 minus D. Then output voltage this one. And calculate the output voltage. After that, calculate output current. Then you can calculate the RMS current of switches. Then what will be given in the questions and quantity. 40 milliohm is given. MOSFET on resistance. Point end voltage. The duty ratio is 0.4. And apply a duty ratio 0.4. Vs is 25 minus 0.8, 1 minus 0.4 divided by 1 plus 0.4 divided by resistance is 1 ohm into R ohm, 40 milliohm. So now calculate this one. Calculate this one, we will find 9.37 volt. V output is 9.37 volt. In ideal cases, you know about V in buck converter dVs. Duty ratio is 0.4 into 25 is equal to 10 volt. But due to the voltage drop across the resistance of MOSFET on resistance and forward voltage drop of diode, the output voltage is 9.37, less than the 10 volt. And what is the output current? Output current is V output divided by a resistance. Resistance is 1 ohm. Then 9.37 divided by 1. 9.37 ampere. Now what will the RMS current of switches? we take as output current is constant. This one is constant. Take the same as IL, average current. Then what if the switch current? Switch current, when switch is on, and that time current is flow of IL. This one. Look here. When switch is closed, and that time this current, same flow of IL current is flow through the switch. And switch is off, then switch current will be 0. And you can say that same current flow here. Switch is on, I naught. Average current of IL is same as average current of I naught. Remaining time is 0. But if you take IL as a ripple, so in dt time period, total time period, then in that time what is switch current? Same as when switch is on, then same IL current flow through the switch. This will be same. You can say as IL maximum, this one IL minimum. Changes between them, you can take a delta IL. And average of this one, same current, average of this one is a I naught. You can take same. If you take averages, if you calculate the RMS switch current from here, then you calculate the easily by apply the formula of square wave. This is so the same as square wave current. Then what is RMS switch current? RMS switch current is root and magnitude square or not squared, whereby 1 into what time period is present, dt. Sorry. dt time divided by t. I think
I naught into the root d.
I think screen is stuck here. Not so. Wait. So okay. Then I naught you can calculate here I naught of root dt ratio. The switch RMS current. This one will be I naught is 9.37 into root of dt ratio 0.4, 5.926 ampere. What is the power loss?
Sir,
Yes.
here we cannot take that triangular shape of current in the RMS quantity.
This one.
Huh?
Yeah, you can take this one. It will take a long time. No
Because
long method.
we have taken that average current
I
DC.
okay. Will just wait. I calculate both condition.
Okay.
I will calculate. And what is the power of this one? 5.926 current into or not, it is 40 milliohm. So it will be 1.4 watt. To calculate this one,
Hmm.
this one is dt, 0 is one time period of t.
Okay.
Now to calculate this time period, this current, this whole current is occurs here, appears on the switches, then what will be the RMS value of this one?
I0 into root D plus delta L by root 3 bracket square root 2.
Yeah, you can calculate this one like that. If you will take as a,
DC component plus AC component.
yes, yes. If you have this one, then you can calculate this like that. But this was not actual directly AC. Then,
Delta I.
yeah, yeah. RMS of any quantity, if you calculate, then you know about the integration of one time period 0 to 2 into integration of current from 0 to whole time period. Where is this one? Waveform is present. Then first of all, find the current expression. If you have this current expression, then you can calculate the RMS directly. Then what will be the expression of this waveform, this line? The same as 0 to I max. Can you retain as this one like I max minus of I minimum into time period plus I minimum, like that. Divided by dt time period. This one is current, initial current. If you take this line only, you take this one 0 to I max, like y minus y1 is equal to y2 minus of y1 divided by x2 minus x1, x minus x1, like that. Take y2 maximum value, IL maximum minus y1 is I minimum, x2 is this one dt time, this one is time scale, dt time, x2 is same as the time, noted the time period, and x1 is 0, dt minus 0, it means IL maximum minus I minimum, IL maximum minus IL minimum into dt minus 0 to x minus x1, x is t and x1 is 0, then it will be t plus y1 is I minimum, then I minimum is go there, then I minimum is here. Then you can find the expression of this one, this line is I maximum minus I minimum into t divided by dt plus I minimum. If you have expression of this one, then you can square of this one, and after that to find the RMS value. Sorry, this one is not, this one is square for RMS value. Root mean is square. Root, this one mean, this one is square. You want to understand how to find the expression of this current. Take y as I and x treat as t. Then you can say like I minus I1 is equal to I2 minus I1 divided by of T1 T2 minus T1 into T minus of T1. Here I1 axis, can say here is first denoted as the x-axis, this one is the x-axis, this one is the y-axis. If you denote this coordinate, then you can say as T1 into T1 and I1. This one is a T2 and I2. T1 is this one, and T2, I1 I2 is this one. Then I minus I1, I minus I1. I1 is this current, is I minimum. I minus I minimum is equal to I2. I2 means this one. Second y axis, y2 is I2 is IL maximum. I maximum minus of I minimum divided by of T2, this one time as dt minus 0, because of this one is take as a origin. This one T minus T1 is 0. Then what is the expression of current? I max minus I minimum. Can say this one is a delta L divided by dt plus of I minimum. So okay for everyone. Then what is the minimum current? Minimum current, can calculate this one. I naught minus of delta L by 2. This one is the minimum current, and of inductor same current flow through the switches also. Then finally current you can find delta IL divided by dt plus of I naught minus delta IL by 2. Then integrate this one to find the I switch RMS. Root of,
There will be T coming,
yes,
delta IL upon dt into T.
yeah.
It is linearly varying.
Yes. This one T, this T minus 0, I am missing this one. Integration of this one 0 to T time period only percent I square into dt. I square this one, I RMS square, so I take I1 by T. Don't be take a silly mistake to add this one delta IL by dt into T plus this one. Can't connect to like that. That's why take as a separate only. This will be I square. It means this one will of a whole square. This total is the current. If you take I square, this means the whole square of this one. If you do square this one, then you find out delta IL square divided by of dt into t square plus I naught minus of delta IL divided by t square a square plus of b square plus 2ab, then 2
The square
into,
won't come.
yes,
This I naught minus delta L by 2 whole square. That won't come right. That whole square won't come right.
yeah, this one is not a whole square. So, I naught minus delta IL by 2. This will be a constant delta IL by square divided by t, only time varying in dt integration. This one t square integration of tq by 3 the IL square divided by dt into t q divided by 3 plus this one is a constant I naught minus of delta IL divided by 2 square into t plus of 2 delta IL divided by dt into I naught minus of delta IL divided by 2. This one t is t square divided by 2 only, 0 to dt. Replace t to dt. Let's no, I remove this one. All of a t present in all the term t q t and dt square. If you place the t as a dt, then t replaces with a dt, but when you place as a 0, then all of equal to 0. That's why I don't take as a 0, don't take a 0 term, only take a dt term. Then this one is so I place as a mistake here. If you square this term delta IL by dt into t square, then delta IL square into t square divided by dt square also. Okay. delta IL square into dt square into dt of q divided by f3 plus I naught minus delta IL divided by t square into dt plus up to delta IL divided by of dt to I naught minus delta IL divided by t into dt square divided by 2. So take cancel out of bt square of this one and this dt, this one dt, and only one dt present here, then tt will cancel out all t, and you find only delta IL square into d by 3 plus of I naught minus delta IL divided by t square into d plus of 2 delta IL can cancel out these two and these two also, then you find I naught minus of delta IL divided by 2 into d. Next one, this one also, d into I naught square plus of d into delta IL square divided by 4 minus of 2 I naught into delta IL by 2 into d. This term I written here a little, plus of d I naught into delta IL minus of d into delta IL square divided by 2. To cancel out, then del d I naught delta IL, d I naught delta IL cancel out. This I naught term present, this delta IL into d, delta IL into d, delta IL into d. Take LCM as take a d I naught square plus 12 as LCM of 4, 3 and 2. Then this will open 4 d into delta IL square plus of 3 d into delta IL square minus of 6 delta IL square into d. Finally, you will get I switch RMS square is equal to d I naught square plus of del d into delta IL square divided by of 12. I switch RMS current is equal to root of d into I naught square plus delta IL square divided by f12. Yeah, you can take as common of d here. This one is the RMS current of switch passing through switch in buck converter.
You have taken only the dt time
I
in the
naught.
equation
Yeah,
where
yeah.
y to y, so it should be double now.
If you calculate this one, this is a very less na delta IL square divided by 2 into d.
No, start from the
This,
starting waveform you have
yeah,
taken.
I will
Why
taken
to
like I yes,
Y1 you have taken only
I switch
to
RMS
DT.
current. I
You
will
have,
taken like I not into root to D. This one only.
yes.
That's I have taken as a approximation value. Then you can calculate this one. It's a very less value. If you want to calculate, then first one calculate delta IL. Delta IL is a Vs in minus of V naught into D divided by of FL. From this you can calculate Vs, V delta IL. This one is a 25 micro Henry. Vs is 25, V naught calculate 9.3 some 9.37.
So please see in the waveform when you started the waveform.
Yes,
Just show me the here. So you have taken only the first slope, positive slope.
this one.
So RMS, if you see
Yes, yes,
T1 I1, then T2 and I2, means you have taken only up to the half cycle, means
yes,
DT up to half DT.
yes.
So and you have divided by T. So it means identical value will be there in the second half.
No, this one is a switch current. A switch current not present in that this time period. But this waveform is a one
Okay,
cycle.
okay, yes,
You
yes.
take in
Yeah,
one cycle. This one is the one cycle.
yes.
That's why you take dt divided by t. The total time period is a
DT
t
divided.
only.
Okay, thank you.
Yeah, but this
Yeah,
one
yeah.
waveform
Okay,
present
sir.
only of on time period.
Yeah, okay, sir.
This one is 25. This one is a 9.37. This duty ratio given 0.4 I think. Frequency 25 microhenry. Frequency is given 1 megahertz. Then calculate this one. 1 megahertz into you can say like 1 10 to the power 6 into 25 into 10 to the power minus 6. This one is will cancel out. The duty ratio is 0.4 I think. So now 0.25 ampere. Then what will delta IL by square wave by 12? The square of this one divided by 12. Then you find this one 5.2 into 10 to the power minus 3 ampere. If you calculate this one, IS RMS of root duty ratio 0.4, O naught is 9.37 square plus of this one 0.0052. Then what will the RMS current? .92 ampere. This one I think same. Are you understand this one? Everyone?
Yes, sir.
Actual RMS current, RMS switch current is this one. I naught square plus delta IL square divided by 12. You calculate but this one I have to directly calculate I naught divided to T is because of the DC component at the maximum here, ripple is very less. That's why you can calculate as a approximation, take as a approximation and calculate this one as a easy by the easy method. If you want to the whole circuit calculation, then you find same, I think. Okay, everyone, I want to stop here. Okay, thanks to all.